In December 2021, a weapons elevator on the world's most advanced warship stopped working. Not during a test, not in dock. During combat operations in the Middle East, the USS Gerald R. Ford, a $13 billion bet on the future of American naval power, couldn't lift missiles to its fighter jets. For 3 days, the most technologically sophisticated aircraft carrier ever built was firing blanks. This is the story of what happens when you try to reinvent a weapon that's worked for 80 years, when you replace steam with lightning, when you build a floating city that can launch a fighter jet every 20 seconds, when you ask, can America still build the impossible? This is what truly separates the USS Gerald R. Ford from all others. The Nimitz-class carriers have ruled the seas since 1975. 10 nuclear-powered floating air bases, each carrying 90 aircraft, each projecting American power across 1,000 miles of ocean. But by the early 2000s, the Navy had a problem. These ships, marvels of Cold War engineering, required 5,000 sailors to operate. Their steam catapults, descendants of technology from World War II, could launch 20 planes per day before needing maintenance, track hypersonic threats. Their electrical systems couldn't power directed energy weapons. The world was changing. China was building carriers. Russia was fielding ship-killer missiles that traveled at Mach 9. Iran was deploying swarm boats packed with explosives, and America's carrier fleet was still using steam. So in 2005, the Navy made a decision. They would build a new class of carrier, the Ford class, that would incorporate 40 years of technological advancement in a single hull. It would use electromagnetic aircraft launch systems, computer-controlled arresting gear, dual-band radar that could track a baseball at 200 miles, a nuclear reactor generating 3 times the electrical power of a Nimitz-class ship. It would require only 4,500 sailors instead of 5,000, saving $3 billion in operational costs over the ship's 50-year lifespan. It would launch 270 sorties per day, versus 140 for Nimitz. Revolutionary. In practice, it would become the most controversial warship America ever built. Let's start with what makes the Ford different and controversial: EMALS, the electromagnetic aircraft launch system. For 80 years, carriers used steam catapults. Jet from 0 to 170 miles per hour in 2 seconds. Simple, reliable, brutal, but inefficient. Steam catapults required massive boilers. They broke down constantly. They couldn't adjust thrust precisely, meaning delicate. Aircraft like drones or future unmanned systems couldn't launch without being torn apart. EMALS changed everything. Instead of steam, it uses magnetic fields, like a railgun. Linear induction motors accelerate the shuttle smoothly, with a wingly, computer-controlled precision. You can launch a 70,000-pound F-35C, or a 20,000-pound drone, with the exact force needed. In theory, in 2017, during initial testing, EMALS failed repeatedly. President Trump visited the Ford and famously said, "The digital catapult system, they want to lower the amount of force. And they're spending hundreds of millions of dollars." I said, "You don't use steam anymore for catapult?" "No, sir." I said, "Ah, how is it working?" "Sir, not good. Not good. Doesn't have the power." He wasn't entirely wrong. Early EMALS tests showed failure rates 10 times higher than steam systems. The Navy had promised it would work. It didn't. Engineers scrambled. Software patches, hardware redesigns. By 2019, the system was functional. Not perfect, functional, but the damage was done. Congress started asking questions. The Ford became a symbol, either of American innovation or American hubris. Nine. Then there were the elevators. The Ford has 11 advanced weapons elevators, electromagnetic lifts designed to move bombs and missiles from the ship's magazine to the flight deck in seconds. Faster, safer, more efficient than the hydraulic key. more efficient than the hydraulic elevators on Nimitz-class carriers. Except they didn't work. For 4 years. The Ford was commissioned in 2017. By 2019, only 2 of 11 elevators were operational. The ship deployed to the Atlantic with hand-cranked backup systems, sailors manually hauling 1,000-pound munitions through the bowels of the ship like it was 1945. A Navy captain died during elevator testing when a mechanical failure caused a sudden drop. The investigation revealed systemic problems, software bugs, rushed construction, inadequate safety protocols. By 2021, all 11 elevators were certified. Barely, and then came the Middle East deployment. The Ford was conducting strike operations against ISIS targets in Syria. FA-18s needed paveway laser-guided bombs. The elevator carrying them froze. For 72 hours, maintenance crews worked around the clock. Fighter jets sat idle. The ship that was supposed to launch 270 sorties a day couldn't launch any. Eventually, they fixed it. But the question lingered. If this happens during a real war, against China, against Russia, what then? The Navy's answer. We're learning. But here's what the critics miss. The Ford's problems aren't bugs. They're birth pains. Because underneath the elevator failures and catapult controversies is something genuinely revolutionary. The electrical system. The Ford generates 600 megawatts of electrical power. That's enough to power a city of 100,000 people. 3 times more than a Nimitz-class carrier. Why does that matter? Because the future of naval warfare isn't just fighter jets. It's laser weapons. Carriers can't do it. Their electrical grids are already maxed out. You can't retrofit a 1970s ship with 2020s weapons. But the Ford was designed for this. In 2022, the Navy tested a prototype laser weapons system aboard the Ford. It successfully shot down drones and disabled small boats. Silently, no ammunition, no missiles, just directed energy. Cost per shot, less than $1. Cost of a single Tomahawk missile, $8 million. That's the future. And only the Ford class can handle it. The same electrical power runs the EMALS catapults, the electromagnetic elevators, the radar systems. It's all integrated. One massive power grid that can be dynamically allocated. If you need more power for radar during an air defense mission, you get it. If you need more power for lasers during a surface engagement, you get it. The Nimitz-class carriers are like cars with separate engines for steering, braking, and acceleration. The Ford is a Tesla. Everything runs on one system when it works. It's unstoppable. But ships aren't just technology. They're people. 4,500 sailors live aboard the Ford. They sleep in berthing compartments stacked 4 bunks high. They work 12-hour shifts in engine rooms, where the temperature hits 120 degrees. They launch fighter jets in storms. They load bombs in the dark. And they've had to learn entirely new systems. Senior chiefs who spent 20 years on Nimitz-class carriers had to relearn everything. Steam catapult operators retrained on electromagnetic systems. Hydraulic elevator crews studied software interfaces. Some adapted, others didn't. Morale became a problem. Sailors called the Ford the most advanced ship that doesn't work. Retention rates dropped. The Navy had to offer bonuses to keep experienced personnel from leaving. But something shifted during the 2022 deployment. The Ford spent 8 months in the Atlantic and Mediterranean. It conducted flight operations non-stop, launched over 10,000 sorties, supported NATO exercises, shadowed Russian submarines, and it worked. The EMALS catapults, 95% reliability. The elevators, all 11 operational. The crew, they became believers. A lieutenant aboard the ship told a reporter, "We stopped asking if the Ford could do what the Nimitz does. We started asking what the Ford can do that the Nimitz can't. That's the difference. The Ford isn't trying to be a better Nimitz. It's trying to be something else entirely." a platform for the next 50 years of warfare, a ship that can fight wars we can't even imagine yet, and slowly, painfully, it's becoming that ship. So what does the Ford mean for American naval power? 3 more Ford-class carriers are under construction. The USS John F. Kennedy, the USS Enterprise, the USS Doris Miller. Each one benefits from lessons learned on the Ford. The Kennedy's EMALS system is already outperforming the ship. Ford's, the elevators work from day one. The costs are dropping. The Ford cost $13 billion. The Kennedy will cost $11 billion. By the time the Enterprise launches, the Navy expects costs around $9 billion, cheaper than the final Nimitz-class carriers when adjusted for inflation. But the real question isn't cost. It's relevance. China now has 3 aircraft carriers and is building a 4th. They're not as advanced as the Ford yet, but they're improving fast. And they're building something else, DF-20 anti-ship ballistic missiles, carrier killers, missiles that travel at Mach 10 and can theoretically sink an aircraft carrier from 1,000 miles away. So why build massive? Why build massive, vulnerable carriers at all? The Navy's answer: because nothing else can do what they do. A carrier strike group projects power across 1,000 square miles of ocean. It provides air superiority, strike capability, electronic warfare, missile defense, and humanitarian assistance, all without needing permission from a foreign government to land. No airbase in Japan or South Korea can match that flexibility. And the Ford's technology, EMALS, advanced radar, integrated electrical systems, makes it more survivable than older carriers. It can launch aircraft faster, meaning more fighters in the air during a missile attack. Its radar can track hypersonic threats earlier. Its laser weapons can intercept swarm drones. Is it so invincible? No. But it's the best answer America has. In 2023, the Ford returned to Norfolk after its longest deployment yet. 8 months. 0 major system failures. 10,000 on sorties launched. The crew lined the rails as the ship pulled into port. Family members waved from the pier. Fighter jets from Carrier Air Wing 8 roared overhead in formation. It was the homecoming the Ford's designers had imagined back in 2005. The vindication the Navy desperately needed. But the story isn't over. The Ford class carriers represent a 50-year commitment. A bet that large deck aviation will remain relevant even as warfare evolves toward hypersonic missiles, autonomous drones, and cyber attacks. It's a bet that American engineering, messy, expensive, frustratingly slow, can still produce machines that change the world. The USS Gerald R. Ford isn't perfect. It's been plagued by delays, cost overruns, and mechanical failures that would have sunk lesser programs. But it's also done other programs, something no ship has done in 40 years. Reimagined what a carrier can be. It's faster, more powerful, more lethal. It launches aircraft electromagnetically, defends itself with lasers, generates enough electricity to power a small city. It carries the weight of American naval dominance on its flight deck. The hopes of 4,500 sailors in its hull, and the future of warfare in its reactors. This is what truly separates the USS Gerald R. Ford from all. Not just the technology, but the belief that we can still build the impossible.